Okay, guys, I'm going to intro section 8.2 for you here. I think you're going to understand it pretty well. It's pretty similar if you've been following what we've been doing. So, if you remember, we had what was called a population distribution. And if you filled it up with dots, which is actually mythical, you can't really do that. But if everything underneath this curve was a dot, every dot represents a person. So like I want the average heights of people at the University of Findlay. Every student at the University of Findlay is one of these dots. You'd represent that with X, okay? Meaning a single person. Then we learned about last week that sometimes you can move to this thing called a sampling curve, and it actually does an extremely good job of tightening this thing up. So what now is happening is every dot in the sampling curve is an X bar. It's an average of, say, 20 people's heights at the University of Findlay. And the strategy here is that this would be a good way of helping us to try to find the truth in case we didn't know it. But so here's what we've got. Population, every student at Findlay is a single dot. A sampling distribution, every dot here now represents a group of people that we've sampled. We took 20 people in this room, 20 people in that room, and you'd create a sampling distribution. Now, if you remember the story, this means in math language that we've got a normal curve, we've got a mean that looks like that, and a standard deviation like that. Now, in the sampling distribution, if you remember, the middle is the same. We talked about that last week, why that would be kind of intuitive, that would be the same middle in both of these. But because when you take samples, it improves your chances of finding the truth, every sample mean is a better guess than an individual. It tightens things up. This is a narrower curve than this one was. I should draw it like that. Like it's much tighter than this one was. Okay, that was last time. What are we doing today? Well, what's happening today is just this one simple change. What we're looking for sometimes is not a mean. Like this was the average height of students, the average admission score, the average dexterity of a 5-year-old in preschool. You take a score, you could average these, average height, whatever. But that's not always what the story is about. Sometimes you're looking for something that isn't quantitative, but it's categorical. So for instance, what I want to do is say, how many people are going to vote for the senator in the upcoming election? Or I say, are you going to vote for the senator? Well, the answer to that question is yes or no. Are you happy at the University of Findlay? The question is yes or no. And so in these circumstances, I'm not looking for a mean. That's not a test score. It's not an average height. What it is a proportion. There's some number of people out of all of the people who are happy at the University of Findlay, X divided by N. That's a proportion I'm looking for. It's not a mean. But otherwise, the story stays pretty much the same. So we're now interested in a proportion. So we've got a sampling curve again. And in the middle of this curve is that true proportion. Now, I don't have time to ask everybody at the University of Findlay if they're happy. I would like to know what that is. But I can sample 20 people at a time or 50 people at a time, and I'll get a dot here. That will be a group of people, which is now, this was X, this is X bar. This is P, the truth for everyone at Findlay, the parameter. The statistic is P hat, okay? This is what the dots represent, just like X bar. It's the same idea. Now, what's the rest of the sampling distribution? So here's how we would write this in math language. The middle of this sampling distribution is P. It's the truth about the whole population, which is really helpful if I were trying to find that. And the standard deviation is PQ divided by N, and all of that is square rooted. So if you remember, we talked about Q before. That's just the complement of P. So if P is there's a 40% chance people are happy at Findlay, I hope it's better than that, then there's a 60% chance that they're not. Divide that by N and make sure you square root all of that, okay? So make sure you're being careful there. So these problems are going to work exactly the same. So we have a sample proportion of 0.35. We want to know the probability that p hat is less than 0.35. You're going to do a normal CDF on this. You're going to go from negative infinity up, so I'll shade that in. You're going to go from negative infinity to here. The problem is going to give you, so negative 1 e to the 99th, comma, 0.35. And they tell you that the true population proportion is 45%. You got to make all these decimals. So the truth is 45% of the people have been to Hawaii. Let's change it because those are bad numbers for happy people at Findlay. The truth of been to Hawaii is 45%. So we take a sample and we got 35%. We want to know what's the probability of being less than that. So negative infinity to 0.35. Here's our mean. And we got to crunch this new standard deviation. This p is this one, the 0.45. So 0.45 times 0.55. And we are taking samples of 50 people, say. So it works exactly the same as it did before. But now we have this instead of this, because what we're talking about here is a proportion. It is not a mean, it is a proportion. So our sampling distribution looks like this. The problems are all the same, including inverses. You can do all of those things, but you now are having these decimals to represent your proportions. Yeah, I think that's all I'm going to say. If you need any help with any of these, please just ask. A couple of the problems on the activity are at the end are going to start asking you to find p hat. They'll say something like 15 out of 20 people in your sample were happy or will vote for the senator. So you have to calculate p hat, 15 out of 20. And then they'll also give you this one. So they'll say, hey, suppose the truth is 40% of the ones that are happy, or whatever the story's about. So if you have any questions, though, just ask. I'd be glad to give you a hand.